Hello, and thank you for your interest in our flood mitigation initiatives at the Rossdale Water Treatment Plant. My name is Yolanda Casiero. I'm a project manager at our Edmonton Water Treatment Plants, and I'll be going through some of the concepts that we'd like to put forward for your input. We will be going through at a high level some of the project context, but we do have another video that goes through all the flooding risks at our water treatment plants for more context and detail. Just to start, what's showing here is a flood inundation map at a 1 in 500 return period. And it shows the Rossdale Water Treatment Plant, Remax Field, Rossdale Neighborhood, and Fire Station 21 to help you orient yourself. The little blue building to the left of Fire Station 21 is our low lift pump house. That is where we take raw water out of the river and bring it into the treatment plant for purification. Just south of Remax Field, you can see a rectangular shape that is, it looks like a grassy field from the surface, but those are our treated water reservoirs. And you can see that at both the low lift pump house and our treated water reservoirs on site at the Rossdale Water Treatment Plant are being inundated with flood water in this scenario. For a little bit of history, the photo that's shown on this slide is the low-level bridge in Edmonton. You can see the Hotel McDonald's in the background, and that is the flood of 1915, just showing you how high the water got. That corresponds to a 1 in 200 return period flood. So this flood would be approximately 1 meter higher than what you see there. That bridge was new at the time, and some brave soul drove a train out onto that bridge to provide a little bit of extra weight to try and help that bridge from washing out during that flood. So to protect the Rossdale site, we're showing a combination of earthen embankments and flood walls at various locations around the site. There's some areas where we'd like to maintain a flood wall, but for the most part, there is some flexibility whether we use walls or earthen embankments, and we would certainly like your input as to which of those is preferable and how you'd like the area to look and feel. One of our drivers is to minimize our environmental impact when we do this work, and another is to coordinate with the City of Edmonton initiatives. We have the River Crossing Project, the Touch the Water Project, and the Ribbon of Green Master Plan that we've taken into consideration when we were coming up with these concept designs. So here's a look at that Rossdale site. Next to the letter C at the bottom, you can see low lift pump house labeled. Between the letters A and B, you can see the underground drinking water reservoirs labeled. And what's shown in yellow is currently proposed as a flood wall. What's shown in orange is currently proposed as an earthen embankment. As I mentioned, there's some flexibility, except in a few select areas. Next to the letter B, up and down, so in parallel with the street, that could be either an earthen embankment or a flood wall. And perpendicular to the street, so going back and forth between that little white box that's up there and the street itself, there's some buried infrastructure. We have some pipes that run in that same direction going towards 101st Street there. And the technical requirements for this project dictate that we should not be putting earthen embankments directly over and in line with underground piping. So in order to avoid that piping, we just need to keep that due to space restrictions as a wall in that area. But you can see that it transitions to an embankment as you move towards the letter A. In that area, we could go either way. Down by the low lift pump house at the letter C, directly in front of the pump house, we're showing a flood wall at this time. When we would switch to an earthen embankment, there's a high potential that we would end up fairly significantly impacting that walking trail that's there and some of the vegetation that goes down the bank. In the area in between the flood wall that kind of comes up in between some of those site buildings and wraps around what's currently a small park there is shown as a flood wall. On the site in between those buildings, we'd like to maintain a flood wall due to space limitations. But as we transition over into the graph, we could switch either way between a flood wall or an earthen embankment. So if you were to stand at the letter A and take a slice through it, pick it up and look at it from the side, this is what you could see. The Remax field would be off to the left. That roadway in between Remax field and the underground treated water reservoirs is shown as a driveway in this diagram. And then there's that earthen embankment and what that could look like. Taking another look at that same area, you can see the underground treated water reservoir on the left-hand side, the embankment, what would be the road, and then a bit of a step down. In this diagram, you can see how high up the water could get at a 1 in 500 return period. And you can also see what's labeled as a buffer zone. So that's an extra meter of safety to account for any unexpected conditions in the modeling. And then in green, you can just see that embankment and what it might look like. If you were to stand at the letter B, take a slice through that and pick it up and look at it, this is what you could see. This one's approximately 1 meter tall, and you can see the existing walkway and existing landscaping along 101st Street in that area, and that grass-only zone. The grass-only zone is there to ensure that the area next to the wall could be inspected. We want to ensure that we don't have any burrowing animals creating flow pathways underneath these walls as we put them in, or embankments. We want to ensure that aggressive root networks from trees or shrubs don't also create flow pathways underneath. And those root networks, while strong, while the vegetation is healthy, once that vegetation dies or starts to decay, it can also create flow pathways underneath of walls or embankments, or could even lead to grouped failure if that were to get washed away. So as I mentioned, we could go back and forth between a wall or an embankment in many of these areas. So where you see a wall depicted in this diagram, there in the same location is an embankment depicted. You can see how high up the water would come in a 1 in 500 scenario, and that buffer zone, that extra meter to account for any unexpected conditions. So if you were taking a walk and we're passing our treated water reservoirs and look southwest towards the plant, this is what you could see. The fence existing is shown there, and the height of that wall is superimposed onto the diagram. And then finally, taking a slice through the letter C down near that low left pump house, picking that up and taking a look at that from the side. The wall is a little bit taller, approximately 1.75 meters. We need to maintain our security fencing, so there'd be an extra approximately ½ meter that we'd need to put on top of that wall. You can see the existing pathway, the grass-only zone for maintenance and inspections, and existing landscape. And looking again at what that could look like in terms of how high the water gets. So you can see the North Saskatchewan River coming partway up that flood wall and the extra meter buffer zone to account for unexpected conditions. If you were to take a walk down the path towards the Walterdale Bridge, this is what you could see. So where there's an existing fence right now is what would be transitioned to a flood wall, and that little bit of extra security up on top. So at the start, I mentioned that we were looking for some input from you. There are a lot of different ways that we can treat these walls or embankments. There's room to input interpretive signage, perhaps some art, some architectural features into the walls to beautify them, and deter graffiti if that were to be a concern. And as I mentioned, areas where we can switch back and forth between walls and embankments. You can get in contact with us by phone at 780-412-3599, by email at waterprojects@epcor.com, or you can find us online at epcor.com/Rossdale. We'd very much like to have your input and feedback on these concepts and what you'd like the area to look and feel like, how you currently use the area, and some ways that we can integrate this into the neighborhood in a positive way. I'd like to thank you for your time and look forward to your feedback.